Hi, I'm Bob. Welcome back to the solutions to the exercises for the textbook Microeconomics Theory and Applications with Calculus, the 5th edition, by Professor Jeffrey Perloff. We are at the third section of Chapter 17. It is related to how to regulate externalities. Let's solve exercise 3.1. Various countries, including Australia, Ireland, and the United States, require that firms sell more fuel-efficient light bulbs instead of incandescent light bulbs. These restrictions were designed to reduce carbon and global warming. What alternative approaches could be used to achieve the same goals? What are the advantages and disadvantages of a ban relative to the alternatives? The alternative to a ban is subsidizing fuel-efficient light bulbs or imposing a tax on inefficient light bulbs. By reducing the marginal cost of using fuel-efficient light bulbs or increasing the marginal cost of using fewer inefficient light bulbs, consumers will purchase more efficient bulbs. Another way is increasing the electricity price. It will widen the cost gap between using the two types of light bulbs. It also encourages people to use more fuel-efficient light bulbs, although it affects other electric appliances. The alternatives enable consumers who are fond of incandescent light bulbs to keep using them. People will have fewer choices if the government bans them. Let's address exercise 3.2. A researcher found that limiting the number of liquor stores reduces crime. To maximize welfare, taking into account the harms associated with alcohol sales, how should regulatory agency set the number of liquor licenses? Should the profit-maximizing owner of a liquor store lobby for or against tighter restrictions on licenses? The supply and demand diagram shows that the social optimum quantity, QS, is lower than the competitive equilibrium quantity, QP. The regulatory agency should set the number of liquor licenses at QS. The private producer surplus is the area C plus D plus E at the competitive equilibrium. It is A plus B plus C plus D at the social optimum. The difference is A plus B minus E. It could be positive, and the producer would be better off at the social optimum. If this is the case, the liquor store owners have no incentive to lobby against the restriction. Let's answer exercise 3.3. Many jurisdictions strictly limit sales of hard liquor in an effort to limit the associated negative externalities. One approach is to impose a high tax on sales of such products. Another approach is to require sellers to obtain licenses and to limit the number of licenses to the socially desirable number. Often, the government sells these licenses to the highest bidder. However, in other jurisdictions, the government sets the price of licenses at a low enough level that expensive excess demand for licenses occurs. For Part A, under what circumstances would auctioning licenses be equivalent to a tax? If the government knows the demand curve and the marginal cost curves, it can either set a tax or the number of licenses to achieve the social optimum quantity QS. As the graph shows, the after-tax private marginal cost curve goes through the social optimum ES, at which the market produces the optimal amount of alcohol QS. Equivalently, the government can limit the number of licenses so that QS units of alcohol are produced. For Part B, what might regulators or politicians favor underpricing of liquor licenses? To set a quota of licenses, the government can achieve the socially optimal quantity of alcohol provided. Licenses can be auctioned and traded so that the producers with the highest willingness to pay or the lowest marginal cost get the licenses. If the licenses are sold to regulators' friends at low prices, their friends can earn a profit by selling the licenses. Let's go to exercise 3.4. In 1998, the National Highway Traffic Safety Administration distributed the film "Without Helmet Laws, We All Pay the Price." Two reasons for this title are that some injured motorcyclists are treated at public expense, and that the dependents of those killed in accidents receive public assistance. For Part A, does the purchase of a motorcycle by an individual who does not wear a helmet create a negative externality? Explain. Yes, riding a motorcycle without wearing a helmet imposes a negative externality on society. It harms others and society for the reasons mentioned in the exercise. For Part B, if so, how should the government set a non-helmet tax that would lead to a socially desirable level of motorcycle sales? As the supply and demand diagram shows, riding a motorcycle without a helmet imposes a negative externality on society, which is described by the externality marginal cost curve, MCE. The private purchase of motorcycles does not consider the externality cost, but the social marginal cost curve includes it. It leads to a private competitive equilibrium quantity of motorcycles purchased, QP, which is too high compared to the social optimum QS. The government can impose a no-helmet tax on sellers equal to the externality cost at the socially optimal quantity. The sellers internalize the externality, and the after-tax private marginal cost curve goes up and passes through the social optimum ES. The after-tax competitive equilibrium quantity equals the socially desirable level of motorcycle sales, QS. If the tax is imposed on buyers, it shifts the demand curve to the left. The intersection of the seller's private marginal cost curve, MCP, and the buyer's after-tax demand curve, D', determines the new equilibrium quantity of motorcycles sold. which could equal the social optimum QS. However, it will be difficult to enforce the tax because we don't know whether people will wear helmets when they buy motorcycles. Let's solve exercise 3.5. In the paper mill example in this chapter, what are the optimal emissions fee and the optimal tax on output? Suppose the tax on output is $T per ton of paper per day. It shifts the private marginal cost curve upward. The after-tax private marginal cost curve will be as follows. It should go through the social optimum ES, where the quantity is 84 and the price is 282. We substitute the values into the new marginal cost function and have the tax equal to $84. Let's address exercise 3.6. In figure 17.1, could the government use a price ceiling or a price floor to achieve the optimal level of production? Since the competitive price, PP, is lower than the socially optimal price, PS, the government can use a price floor instead of a price ceiling to force the producers to charge a price no less than the socially optimal price. The price floor is at the social optimum price, PS. The lowest price producers could charge is PS, so the socially optimal output level, QS, is achieved. Let's go to exercise 3.7. In figure 17.3, the government may optimally regulate the paper market by taxing output. Given that the output tax remains constant, what are the welfare implications of a technical change that drives down the private marginal cost of production? We replicate figure 17.3 and then draw the private marginal cost curve, the social marginal cost curve, and the after-tax private marginal cost curve after the technological change. The technological advance shifts the curves downward. We find that as the social optimum quantity increases, the gap between the socially optimal price and the competitive price becomes larger. The constant tax can no longer offset the difference. The new competitive equilibrium quantity is higher than the new socially optimal quantity, leading to a direct loss of the blue triangle area. Let's answer exercise 3.8. Suppose that the inverse demand curve for paper is P equals 200 minus Q. The private marginal cost is MCP equals 80 plus Q, and the marginal harm from gunk is MCG equals Q. For part A, what is the unregulated competitive equilibrium? The intersection of the demand curve and the private marginal cost curve determines the competitive equilibrium. The unregulated competitive equilibrium quantity is 60 and the competitive equilibrium price is $140. For part B, what is the social optimum? The social marginal cost is the sum of the private marginal cost and the externality marginal cost. The social optimum is at the intersection of the demand curve and the social marginal cost curve. The socially optimal quantity is 40 and the optimal price is $160. For proxy, work-specific tax T results in the social optimum. Suppose the specific tax T is imposed on producers. The private marginal cost shifts upward after the tax. The after-tax private marginal cost equals the original marginal cost plus the tax. If it results in the social optimum, the after-tax private marginal cost curve must go through the social optimum, where quantity equals 40 and price equals 160. We can solve for the specific tax, which equals $40. Let's answer exercise 3.9. Connecticut announced that commercial fleet operators would get a tax break if they converted vehicles from ozone-producing gasoline toward the states that were cleaner fuels, such as natural gas and electricity. For every dollar spent on the conversion of their fleets or building alternative fueling stations, operators deduct 50 cents from their corporate tax. Is this approach likely to be a cost-efficient way to control pollution? Cleaner fuels have a positive externality on society. Suppose the commercial fleet operators' private marginal cost and the marginal benefit are constant over the quantity of cleaner fuels they use. The social marginal cost equals the private marginal cost minus the marginal benefit of the cleaner fuels. Compared to the social optimum, the private competitive equilibrium quantity is too low, and the competitive equilibrium price is too high. To encourage more use of cleaner fuels, the government can provide subsidies so that the private marginal cost curve shifts downward until it coincides with the social marginal cost curve. For this graph, the subsidy should equal the marginal benefit. It is uncertain whether the tax rebate in the exercise is exactly the amount needed to achieve the social optimum. Let's solve exercise 3.10. If global warming occurs, the output of 3 of the major U.S. cash crops could decline by as much as 80%. Crop yields increase on days when the temperature rises above 50 degrees, but fall precipitously on days when it is above 86 degrees. Given this relationship between agricultural output and temperature, what would be the government's optimal policy if it could predictably control pollution and hence temperature? Can you use either a tax or an emissions standard to achieve your optimal policy? How does your policy recommendation change if the government is uncertain about its ability to control pollution or predict the temperature? If the government has complete information on the cost of pollution's negative externality on global warming, producers' marginal cost, and the market demand, it could either set a tax or an emission standard to achieve the socially optimal pollution level that results in the optimal temperature for the crop. However, if the government is uncertain about the information, it is impossible to control the pollution level accurately at the social optimum. Whether to use a tax or an emission standard depends on the government's degree of uncertainty and the shape of the externality cost and marginal cost curves. Let's address exercise 3.11. Suppose that the government knows the marginal cost curve of reducing pollution, but is uncertain about the marginal benefit curve. With equal probability, the government faces a relatively high or a relatively low marginal benefit curve. So its expected marginal benefit curve is the same as the one in figure 17.4. Should the government use an emission fee or an emission standard to maximize expected welfare? Explain. If the true marginal benefit curve is MB1, which is higher than the expected marginal benefit curve, the socially optimal quantity will be Q1S. If the government sets the emission standard at QS, the deadweight loss will be the blue triangle area. If the government sets the emission fee at PS, the deadweight loss is still the blue triangle area. We can also prove that if the true marginal benefit curve is MB2, which is lower than the expected marginal benefit curve, the deadweight loss will be the red triangle area, no matter whether the government sets an emission standard or an emission fee. It implies that if the government knows the marginal cost curve but is uncertain about the marginal benefit curve, it can either use an emission standard or an emission fee because they have the same welfare effect. Let's go to exercise 3.12. Spam imposes significant negative externalities on email users. If the sender had to pay a small fee for each email, would the extent and impact of this negative externality decline? What effect would such a charge have on the net benefits arising from long spam emails? How would the charge affect the proportion of spam in overall email traffic? The private marginal cost of spam emails is almost zero. We assume that the private marginal cost curve is horizontal at p equals 0. Spam creates a negative externality, which is described by the externality cost curve MCE. The social marginal cost is the sum of the private marginal cost and the externality marginal cost. So, the social marginal cost curve coincides with the externality marginal cost curve. The socially optimal amount of spam, QS, is lower than the competitive equilibrium quantity, QP. The fee shifts the private marginal cost curve upward. The new intersection of the after-fee private marginal cost curve and the demand curve shows that spam decreases from QP to QS. The fee reduces or even eliminates the deadweight loss of the red triangle due to the negative externality of spam. However, the fee will create a deadweight loss for long spam emails. The competitive equilibrium quantity of long spam emails is Q1 without the fee. The fee shifts the original marginal cost curve upward, leading to a new equilibrium quantity Q2, which is smaller than the optimal quantity Q1. it results in a debit loss of the red triangle area. Both spam and non-spam emails will decrease after the fee. The fee can reduce the debit loss caused by the negative externality of spam emails, but it will create a debit loss for non-spam emails. Without further information, it's uncertain how it changes the proportion of spam in overall email traffic and the overall welfare. Let's solve the last question in this section. Countries around the world provide consumers with fossil fuel subsidies. In 2015, the subsidies reached $5.3 trillion. A researcher estimated that subsidies cost $4 billion in external costs annually. In a figure, show the effect of these subsidies and compare the post-subsidy equilibrium to the pre-subsidy equilibrium and to the social optimum, which accounts for pollution harms. We first compare the post-subsidy equilibrium to the pre-subsidy equilibrium. The graph shows that the subsidy shifts the private marginal cost curve downward because production is less expensive. The post-subsidy equilibrium quantity is higher than the pre-subsidy quantity. The post-subsidy equilibrium price is lower than the pre-subsidy price. We can write the consumer surplus, the producer surplus, the government surplus, and the welfare in a table. The subsidy causes a debit loss of H. Next, we compare the post-subsidy equilibrium to the social optimum, which accounts for pollution harms. Since the use of fossil fuels leads to pollution and imposes a negative externality on the environment, the government should use a tax to shift the private marginal cost curve toward the social marginal cost curve. A subsidy moves in the opposite direction and increases the debit loss. We add the externality cost curve to the graph. The social marginal cost is the sum of the pre-subsidy marginal cost and externality marginal cost. The graph shows that the debit loss is the red triangle area, which is bigger than H. Thank you so much for watching this video and solving the exercises with me today. See you soon. Take care. Thank you for watching this video and subscribing to my YouTube channel. See you next time.